Welcome to Serenity, Game Systems Foundation. In the previous tutorial, we configured the audio player system for UI sound effects like hover and click sounds. Today, we're going to build on top of that foundation with the music player system, Serenity's solution for handling background music and music transitions. By the end of this tutorial, we'll have menu music, gameplay music, automatic transitions, fade-in and fade-out behavior, and runtime music switching. The audio player system we configured previously is designed for short-lived sounds. Music behaves differently. Music usually persists longer, survives menu transitions, fades between states, and often needs orchestration logic. So, instead of mixing both responsibilities together, Serenity provides a dedicated music player aggregate. The music player focuses specifically on background music playback, transitions, fades, playlists, and track management. Just like the rest of Serenity, the system remains declarative and configuration-driven. Copy your music into your desired folder. Then, create the music track definition using the context menu. Configure each definition by populating its ID and assign the proper audio asset. Copy the music track definition and populate it with the gameplay track. Go to the music audio player settings and add a new track to the Unity Audio Game Settings definition track list. Create a new EventDispatcher signal and action. On the action, let's use the system locator to find the iMusic player service. Make sure to provide a proper music track ID and set the track as loopable. Create a new signal and action for gameplay music. In this case, we're going to parameterize the transition as crossfade. That will take 5 seconds to be done. Let's connect the music flow. Open your GameMode settings definition scriptable update. On GameMode transition signals section, populate menu signals and game signals fields with the signals we created before. And that's the entire integration. Any service knows nothing about the music player implementation. It emits signals. The EventDispatcher routes them. The music player reacts, completely decoupled. Due to music player integrates with the EventDispatcher, any system can control music flow at runtime. For example, boss encounters, pause menus, cutscenes, or game mode transitions, with no direct service dependencies, no singletons, no hard references between systems. On showing the menu music track will start. Now we enter on gameplay. Menu music fades out. Gameplay music fades in. In this tutorial, we've created declarative music track definitions, configured the music player servers, connected music to game lifecycle, added gameplay music transitions. We now have a complete audio foundation for UI sound effects, music playback, and runtime audio transitions. And now that we have UI sound effects and music working together, the next logical step is control. In the next tutorial, we'll configure the sound mixer system, separating audio into categories like master, music, and sound effects, controlling volumes independently, and connecting everything to real setting menus to a fully decoupled workflows. We'll finally give the player proper control over the entire audio experience.